Yes students, welcome to our video lecture. We have started definite integral as the limit of sum, and you can say this sums are bit lengthy but very important students from examination point of view. So today we are starting with the fourth sum of exercise 7.8. Now all of you please concentrate. So we start with according to definition, integral 1 to 4 x square minus x dx is equal to limit h tends to 0 h into bracket f of a plus f of a plus h plus f of a plus twice h up to f of a plus n minus 1 into h. Here fx is x square minus x, h is equal to b minus a upon n, 4 minus 1, 3 by n, and n tends to infinity students. Then we have h tends to 0. So substituting this value students, we have limit h tends to 0, h is 3 by n, f of a is 1, so f of 1 will be 1 square minus 1, so you can say 0, f of a plus h will be f of 1 plus h, and h is nothing but 3 by n. Then this will be a plus twice h, so 3 into 2, 6 by n up to f of 1 plus n minus 1 into 3 by n. Now in the next step, we substitute the values, so limit h tends to 0, 3 by n. f of 1 plus 3 by n will be 1 plus 3 by n whole square minus 1 plus 3 by n. f of 1 plus 6 by n will be 1 plus 6 by n the whole square minus 1 plus 6 by n up to f of 1 plus n minus 1 3 by n will be 1 plus 3 by n minus 1 the whole square plus 1 plus 3 by n into n minus 1. Okay students, so this is the simplification students. Here simplification is a bit lengthy but not at all difficult. Now students, I go for simple expansion, so limit h tends to 0, 3 by n, or let me change the limit here only directly. Let us write n tends to infinity. Both limits are correct students, do not worry. N tends to infinity because we are converting the whole sum in terms of n. Now, when I go for the expansion students, pay attention. When I go for the expansion, 1 and minus 1 will be cancelled. Middle term will be 6 by n minus 3 by n. So what will remain is 3 by n, and last term will be 9 by n square. Now this much all of you can understand. If I expand the whole square, it will be 1 plus 6 by n. 6 by n minus 3 by n is 3 by n. Last term will be 9 by n square. Same way here. Middle term will be 12 by n minus 6 by n. So 6 by n. And last term will be 36 by n square. Up to 1 and 1 cancel, middle term will be 6 by n minus 1 minus 3 by n, so 3 by n minus 1, and last term will be 9 by n square into n minus 1, the whole square. So this is how, students, we have simplified. Now from all these first terms in the bracket, from this first terms in the bracket, 3 by n is common. So limit n tends to infinity, 3 by n outside, And if I take 3 by n common, then bracket will give me 1 plus 2 plus 3 up to n minus 1. Now from square terms, if I take 9 by n square common, then students, I will get into bracket 1 square plus 2 square plus 3 square up to n minus 1, the whole square. Now, this term will be sigma n minus 1 and this term will be sigma n minus 1 whole square. Already in the last lecture we have discussed the formula. Limit n tends to infinity, 3 by n into n minus 1 into n by 2. And this will be 9 by n square, n by 6, so n minus 1 by 6 into n plus 1, so n into 2n minus 1. This formula, students, we have already written, but once again as a revision I am writing here, sigma n is n into n plus 1 by 2. So sigma n minus 1 will be n minus 1 into n by 2. Sigma n square is n by 6, n plus 1 into 2n plus 1. So for sigma n minus 1, the whole square, it will be n minus 1 by 6 into n into 2n minus 1. Now, this n and n gets cancelled, 1 n and n gets cancelled. I am multiplying 3 by n within the bracket. So limit n tends to infinity, 3 into 3, 9 by 2. And taking individual division, I will get 1 minus 1 by n. This is 3 by 2 into 3, so again 9 by 2. Taking n common from these two brackets and upon n square, so we will have 1 minus 1 by n, 2 minus 1 by n. Now, this term gets cancelled, and taking the limit 9 by 2 into 1 minus 0 plus 9 by 2 into 1 minus 0 into 2 minus 0. So, it's finally our answer will be 9 by 2 plus 9, 18 plus 9, 27 by 2. Because this 2 and 2 gets cancelled. So 9 by 2 plus 9. This is our final answer, students, which we have to remember. Okay, students, now we go for the fifth sum. Now from fifth sum again, students, the method changes slightly. The method changes because here we have an exponential term. So geometric progression comes into play. So that, students, I suppose all to remember the sum of n terms of G. That, students, we have to remember. Now, students, I am starting the fifth sum, and again I am telling the method slightly changes. Integration minus 1 to 1. Fifth sum. Integration minus 1 to 1 e raised to x dx according to definition. Integral minus 1 to 1 e raised to x dx is limit h tends to 0, h into bracket f of a plus h, f of a plus twice h, up to f of a plus n minus 1 into h. Now, students, function changes. Here, fx is e raised to x, h is b minus a upon n, 1 minus 1, so plus 1, so 2 by n tends to infinity. then h tends to 0. So this changes to limit h tends to 0. Here look at in terms of h. F of minus 1, f of minus 1 plus h, f of minus 1 plus twice h, up to f of minus 1 plus n minus 1 into h. Now, f of minus 1, so limit h tends to 0, h into this is E inverse, this is E inverse plus means e raised to minus 1 plus h, e raised to minus 1 plus twice h, e raised to minus 1 plus n minus 1 h. Now students, throughout E inverse is common. In that I am taking outside limit E inverse limit h tends to 0, 1 plus e raised to h, e raised to twice h, up to e raised to n minus 1 into h. Now students, the next part of the sum is geometric progression. The next part of the sum is geometric progression. This is the GP, where first term is 1, common ratio is e raised to h, and sum of n terms of the GP is a into r raised to n minus 1 upon r minus 4. This we have already studied, students, in 11th standard chapter 9. So this is to be perfectly remembered as well as memorized. So if I apply that, this will change to E inverse limit h tends to 0, h into bracket, a is 1, r is e raised to h raised to n minus 1 upon r minus 1. Now students, this will be E inverse. Always this h we have to bring in the denominator. So limit h tends to 0, e raised to n h minus 1 upon e raised to h minus 1 upon h. Here the new formula of limit is introduced. Limit h tends to 0, e raised to h minus 1 upon h is log a base e, where of course a is positive, because logarithm of 0 and negative number not defined. Now nh, from this we get nh is equal to 2. So this term will always change to a constant, which is e square minus 1. So e inverse into e square minus 1 into limit h tends to 0, 1 e raised to h minus 1 upon h. Now here a raised to h minus 1 upon h, answer is log a. Our a is e, so log e base e is 1. So this limit will be 1. 1 by 1 is 1. So the final answer is e square minus 1 upon e. So e minus 1 upon. So this is our final answer, students. So here some important concepts of geometric progression, students, are taught. Means taught in the sense are applied. Sn is equal to a r raised to n minus 1 upon r minus 1. This is the sum of n terms, students, of a geometric progression. So this is slightly different from the traditional sum because we have exponential term. Okay students, now sixth sum. It is a mixture of exponential and polynomial. Okay students, now I am doing the last sum of the exercise. Students, pay attention. I think by this time you would have become familiar with the traditional steps of this type of sum. Okay, the sum is integration 0 to 4 x plus e raised to 2x. I is equal to integration 0 to 4 x plus e raised to 2x dx. So this will be integration 0 to 4 x plus e raised to twice x dx. So students, here fx is equal to x plus e raised to twice x, h is equal to b minus a upon n, so 4 by n tends to infinity. Then students, h tends to 0. Now, keeping the sum in terms of h, limit h tends to 0, h into bracket f of 0, f of 0 plus h, f of 0 plus twice h, up to f of 0 plus n minus 1 h. Now, you substitute and write the functional values. F of 0 is 0 plus e raised to 0, so 1. F of h is h plus e raised to twice h. F of twice h is twice h plus e raised to 4h, up to f of n minus 1h is n minus 1h plus e raised to twice h into n minus 1. Okay students, we group the terms with h and without h in terms of polynomial and exponential. So 1 plus h, h plus twice h plus up to n minus 1h, so h into bracket 1 plus 2 plus 3 up to n minus 1. Then exponential terms with 1 plus e raised to twice h plus e raised to 4 times h plus e raised to twice h into n minus 1. Now students, this will change to sigma n minus 1. This is a GP where first term is 1, r is e raised to 2h, s then is a, r raised to n minus 1 upon r minus 1. So applying both the concepts at a time, this changes to limit h tends to 0, h into bracket. Again, sorry students, this h I forgot to write here. H into bracket n minus 1 into n by 2 plus, now this is a GP, e is 1, e raised to twice h, so e raised to twice nh minus 1 upon e raised to twice h minus 1. Now students, what I am trying to do, one limit I will keep in terms of, let us keep both the limit in terms of h only. So this will change to limit h tends to 0, nh into nh minus h. This nh as it is, this h in the bracket, plus nh is 4, so this will become the limit h tends to 0, e raised to 8 minus 1 upon e raised to twice h minus 1 upon h. This h will transform this in the denominator. Now, I should have here 2, because whatever the power of e is there in the formula, limit h tends to 0, a raised to h minus 1 upon h is log a base. Whatever power of a, same must be there in the denominator. So multiply and divide by 2. Now, changing this to limit h tends to 0, nh is how much? 4 into 4 minus h by 2 plus e raised to 8 minus 1 upon 2 constant, limit h tends to 0, 1 upon e raised to twice h minus 1 upon twice h. So now taking limit, this will be 2 into 4 minus 0 e raised to 8 minus 1 upon 2. This will be still log e base e, so 1. So the final answer is 8 plus e raised to 8 minus 1 upon 2. 16 minus 1, 15 plus e raised to 8 by 2 is our final answer, students. Calculations are what? Application of concept is wider, so the better you understand, you will be comfortable with this type of sums. So students, we have completed our exercise 7.8, and again I am reiterating, this all sums can be done by direct integration and you can verify the answer. But in exam, when we are told to do by limit of a sum, we have to students go by this traditional approach only. So please be careful that students will apply these concepts very perfectly. You have to understand these sums. So the formulas used in this sums, and once again revise it so that you can understand that these concepts are applied in this type of sums. Students, I am revising all the formulas which are applied in this type of sums, so that you can perfectly understand, students, the basic. The first formula is sigma n, which is n into n plus 1 by 2. Then the second formula is sigma m square, which is n by 6, n plus 1, twice n plus 1. This is not used, but let us write. This is n square by 4, n plus 1 the whole square, and it is equivalent to sigma n the whole square. Fourth formula, summation of a constant is n times the constant. Fifth formula, we are using, you can say, sum of n terms of the GP. So GP is A plus AR plus AR square up to AR raised to n minus 1. Then Sn is equal to A R raised to n minus 1 upon R minus 1. Then two important formulas of limit. Limit n tends to infinity 1 by n is equal to 0. And seventh formula today we apply. Limit h tends to 0, e raised to h minus 1 upon h is log a z, of course, when a is greater than 0. So this formulas you note down and make a list, and even write, or you can say you can attach a pin page with text. This many formulas are instrumental for doing the sums of exercise 7.8. So here we conclude the exercise in the lecture. Remaining from 7.9, we start with the next lecture. Thank you, students.